In this video, we will explain a procedure to read a string from keyboard. Assume that our procedure name is readstr, and first we will create a string, a variable, a byte array with, for example, str1 db50 with no initial value. So corresponding to that, we will have str1 with number 50 locations here. Then before calling our procedure, point si to the starting location of our byte array. Okay, the initial setup for this procedure is like this. After that, we will call the readstr. Then we can consider the definition corresponding to readstr. Okay, this is an assembly language program to read and display a string ending with $sign. In this program, we will use our procedure readstr. So here inside this data segment, we have one msg1, that is a string, enter your string, and msg2, the string is okay. And str1 is a byte array with 50 elements and no initial value. This will be used for storing the string we are reading in this program. So this is our main program between this dot startup and dot exit. So initially we will just display enter your string, and that is displayed by using our display msg procedure. And after that, we will make si pointing to starting location of str1. This str1 is our byte array, and then we will call the readstr procedure. Now we can go to our readstr procedure. This is our readstr procedure. This is a procedure to read a string and store to a memory location pointed by si. Okay. So readstr proc near. This near, what is this near? Significance of near, that we already explained. Then push ax and push si. These two instructions are used to save the contents of register into system stack. Purpose is to prevent side effect, because these two registers are used inside this readstr procedure, so their values may change. So to save their values, we can use these two statements. Okay. Then first we are reading a single character from the keyboard by using the service 01h. Service 01h, that will read a single character, and after reading this single character, that will be available in AL register. Then move that value into our byte array, that is first location in our byte array. Then increment si. Then we will check whether the character is the ASCII value. The ASCII value will be available through the AL register, and after that we will check whether the ended character is the enter key or not. If you are pressing the enter key, then an ASCII value of 0dh will be received. So we are just comparing whether the received character is the ASCII value corresponding to enter key. If it is not, then we again read the next character using this service 01h. Then copy or store that character into our byte array. Increment si. Si will point to next byte location. Compare with enter key. Jump on not equal. JNE means jump on not equal. Go to this label then again read like that. While we are pressing the enter key, then 0dh will be received. So we will exit from this loop and we will reach here. At that time si will point to the, okay, in that case 0dh will be stored into our byte array and si will point to the next location. So that is why we will decrement si. Then we have to replace that 0dh by dollar symbol, because we assume that our string is terminating with a dollar symbol. So move al comma dollar, then copy that dollar symbol into last position of our string. Okay, while we are copying this dollar to al first instead of directly copying into memory, because in the case of 8086 there is no addressing mode for copying a constant value or immediate value into memory location directly. That is why we will first copy that value into a register, then that register value will be copied into memory location. Now the string is stored into the array. Next we have to restore the register values that we have saved at the starting of this procedure. That is pop si, pop ax, restore registers to prevent side effects. While popping these values, we have to pop these values in reverse order, because it's a LIFO, stack is a LIFO. That is why pop si and pop ax. At the starting we have push ax, push si. Just reverse here. Okay. Then this is our return statement, return from procedure. Then read str np. This will mark the end of the procedure read str. And another thing we have to note is this is a label, jump on not equal back. Here we are using a label. So if this condition is satisfied, then this will jump into, this is a conditional jump into this label. So while we are using a label, we can use any name, but that must be unique. That means we cannot use a label that is already used in some other procedure or in main program. That will make some conflict. So we have to check that this is a new label. Okay. Then okay, now we have read the string and that will be available in the str1. Okay. Then to display that string, okay, we are just displaying the message. This string is that is msg2. For that purpose we can use this statement move dx comma offset of msg2 called display msg. Then we have to display the string. For that purpose move dx comma offset of str1, our string. Then call display message. This display message is just to display a message ending with a dollar symbol that we have already created display message procedure. So we'll write the procedure, or we'll arrange the procedure after the dot exit and before the end directives. Okay. So this is about how to read a string and display it by using our procedures read str and display msg. Okay, thank you.